This is part 2 of 2.11, the Bohr atom. The discrete jumps between energy levels are quantum changes. Electrons can move or jump to different energy levels, and as they do that, they lose or gain energy depending on where they are moving. One way to talk about the energy needed to move an electron from one level to another is to refer to a quantum of energy. A quantum is a discrete or specific amount of energy. In Bohr's model of the atom, the amount of energy needed to move electrons is very specific. You may have heard the expression quantum leap used to refer to a sudden or discrete change. That expression comes from the Bohr model in which electrons jump to one level of energy or another, but nowhere in between. Think of those movements of electrons to different energy levels as discrete or quantum changes. So, when I'm increasing the energy, nothing happens until boom, I get to the right amount and then it jumps. Nothing happens, and then boom, I get to exactly the right amount. Okay? So nothing happens, and boom, to the right amount. Now, even if I just go back that little bit, it drops back down to the third one, because anywhere in here, it has to stay on the third level. Once it hits here, it's going to be in the fourth level. So that's your quantum changes. So I'm actually going to grab these two notes right here, and we are going to move them under our definition of quantum, which is a discrete amount of energy. A valence or outer electron is any electron located in the outermost orbital. Some electrons have specific designations and roles in an atom. One such group of atoms is the valence electrons. Valence electrons are found in the outermost orbitals. They are located farthest from the nucleus and have the most energy. The valence electrons are the ones that interact or are transferred to other atoms during chemical reactions. Valence electrons thus help determine the chemical properties of elements. So oxygen has 8 total electrons when it starts out electronically neutral. 6 are in the outer orbital, so oxygen has 6 valence electrons. Aluminum has how many valence electrons? 3. Calcium has 2 valence electrons. So these 2 valence electrons are going to be lost in order so that the next orbital has a full outer shell and calcium is stable. And krypton has 8 electrons in its outermost shell. It's a noble gas. It's not reactive because it already has a full outer shell. Bohr's model will be very useful to your study of chemistry. Bohr's model of the atom, with the placement of electrons in specific orbitals, also called energy levels or shells, outside the nucleus will be useful for most of your studies in this chemistry course. Each electron in an orbital has a specific amount of energy. Electrons can move from one orbital to another, and when they do, they either gain or lose a discrete amount of energy known as a quantum. So that specific amount of energy is a quantum. The electrons in the outermost orbital are called valence electrons, and they play a key role in the chemical interactions between atoms. Atomic models, the outer electrons are named valence electrons. These are the ones that react. These are the ones that can be gained or lost or shared in order to have a full outer shell. And why do atoms want a full outer shell? To be stable. Atomic models developed by Bohr introduce electron orbitals as well as the energy levels. All right, as always, if you have questions, let me know.